So good morning, everyone. So today we are going to start regression on using the Keras neural network. So before we move ahead, few prerequisites I would like to see from your side. So you must have gone through the modules in TensorFlow, basics of neural network, and our image classification modules. So these are the prerequisites to this. If you're not having it, I just highly suggest you to look up my playlist and quickly go through the videos. So it's a good practice to import warnings and filter out all the warnings to avoid all those unnecessary red lines that come in your Jupyter notebook and the old drill based technically. So importing NumPy and pandas, followed by scikit-learn's model selections, train to split functionality, Seaborn for visualization, Keras models and layers and dense to output and batch normalization. And you have the Keras scikit-learn wrapper and as Keras regression. So we'll be importing this, the cross-validation score for k-fold cross-validation, standard scaler for scaling up the data between 0 and 1 or -1 and +1, and the scalar model pipeline. So I'll quickly run this and we'll have today's problem that we're trying to solve is the prediction of the chance of admission for a given candidate in a given university. So once loading the data, we can have a good look. So the independent variables are GRE score, the TOEFL score, the university ranking, the statement of purpose, the CGPA, research. And based on these parameters, we are going to estimate the chance of admission for the given student in a value between 0 and 1. So just see the descriptive statistics. So we have the count, mean, standard deviation, minimum 25th percentile, 50th percentile, 75th percentile, and the maximum value. We will just convert the admission chance into a NumPy array to estimate the number of unique values. We have 60 different values in the column to predict in a data frame of size 500 rows and 8 columns. So this is how we estimate the basic EDA, following which we'll do the correlation. So the default method used by pandas is the df.code. The df is the data frame that you have inputted. And here, what we're trying to do, what it does is it uses the Pearson's correlation coefficient as a default correlation metric. So this is a bivariate correlation method which measures the linear correlation and relationship between the two variables x and y. So we'll just define a figure, make it a subplot, and input the correlation matrix into the figure, set the x and y matrix, and display it. So here we have it. This is our correlation plot. So the color scale on the right shows correlation between -1 to +1. Basically, we do not have any negative correlated values in this correlation plot that we have. That's a good start. And you might be knowing why the diagonal elements are red. If you do not know, it's because the values between the same variables, one-to-one variables, are having maximum correlation of 1. So GRE and GRE has a correlation of 1. Technically, if you increase the GRE scores on this axis, it also increases on the other axis. So it's a symmetric matrix, as you can notice. So we'll use different methods to plot out correlation. This is not the only way to do it. We have the Seaborn heat map, which I prefer in visualizing the correlations here. This looks fantastic. And we'll just do a distance plot in which we estimate the chances of admission using various variables. So we'll set a threshold. If the admission chance of a given student is less than 0.72, we'll label it as that the person hasn't got admission, else it'll be got admission. So red and green will be the labels to indicate not got and got. So we'll just quickly analyze this. So we have not admission based on the GRE scores here. We have TOEFL scores, you have the university rating, and we have the statement of purpose, the CGPA, the research, and the admission chance. So this is like comparing the same variable with a similar one. Hence, you see a wonderful correlation between the two variables here. So I highly urge you to shoot out your doubts in the comment section below. And now we are going to plot out the box plot, basically. So why do we use a box plot here? We make use of a box plot here to understand if there are any outliers in our data. Just scrolling to the box plot here. It looks perfect, except for a few dots here, which is not much. So it's a good statement to say that we do not have any outliers in our data set. So now we are going to estimate the chances of admission based on GRE and TOEFL scores and other parameters in our hands. So firstly, we'll see the GRE scores. So technically, this chart says that the higher the chance of admission, higher the GRE score. So basically, the scale represents between 0 to 1 as a chance of admission. So it works out pretty well. So similarly, the higher the TOEFL score and higher the GRE score, the higher the chance of admission. Right. So basically, we are also seeing a high chance of admission in a GRE score range between 310 plus to 320, despite having a low TOEFL score of 100 to 110. So university rating, the higher the rating and higher the GRE score, the higher the chance. And basically, the higher rating and lower GRE score, as the real world scenario says, the lower chance of getting admission. So statement of purpose also states same. Only unless and until you have a wonderful statement of purpose, you get a high chance of admission in a reputed university. And CGPA, it goes without saying, GPA of about 8.5 is a good threshold to have a high rate of admission in a good university. But it also comes into the consideration that having a good GRE score also matters. So research. So this is a huge distinction. So we have set two values for research, 0 and 1, which says if the person has done research or not. So on analyzing this chart, it goes without saying that if in case you have had a research experience, you are going to have a high chance of admission into a reputed university. Though it has been exhibited that candidates who have no research done in their undergrad years, but have a wonderful GRE score do also have a chance of getting admission of higher than 0.8 in a reputed university. But that is an extreme case here. So admission chance. So higher the GRE score, higher the admission chance. And then yeah, the GRE and TOEFL score, just an inverse relationship of the previous chart, which we have had here. So I will just skip this and leave it for your own research. And yes, the moment you've all been waiting for is creation of the deep learning model that you are going to employ to build the Keras regressor. So the Keras regressor requires an argument known as the baseline model upon which it needs to build. And that is exactly what we are trying to build using this function. We define a sequential model with the input layer of 16 nodes having an input dimension of 7 for the 7 different columns in our dataset. And we have the dense layer having first hidden layer having 8 nodes and the output layer having single node. So since you have extensively worked on classification problems, I understand that you will get a doubt as to why a single layer. So this is because we are dealing with a regression problem. And in regression problems, we have a continuous output, which can be represented by a single node. And we'll compile the model using the mean squared error loss function and an Adam optimizer. An add-on could be using the mean absolute percentage error as the loss function, which can perform extensively well. So we'll define the X and Y as a training and test, and as the independent and the dependent variables. As NumPy arrays, this is how they look like. They look good to go, completely numeric. And now we're going to scale the data. So as you have seen in our PCA session in the data science and machine learning course, we have the min-max scaler, which technically shrinks the data range such that the range is between 0 and 1 or -1 and +1 if they are negative values. So we'll split the data into train test split here. As you can see, using 80 to 20 split, import the min-max scaler from the sklearn's pre-processing package and define the scaler and fit and transform upon the training and testing data. We do not have to apply the min-max scaler across the target variable, which is y. So with the estimator, the Keras regressor, attach the baseline model, which we have defined up here as the, where was I? The build function, 30 epochs. It can also set the higher number of epochs, batch size of 3. and verbosity as 1. So what you can in addition to here is that I have deliberately let out the use of callbacks, which we have explored extensively in our previous session. So try to incorporate callbacks in this. So as an extension to this, to get a better performing model. So we'll fit our model. Okay. Since we are dealing with a regression problem, I understand that you'll be quite surprised to see that the accuracy is missing out. So in the regression problem, especially in regards to neural networks, we estimate the best model using the loss. So the loss is nothing but, in this case, the mean squared error. So it can also be MAPE, it can also be root mean squared error, and so on. All the basic statistical and evaluation metrics you have in the data science and machine learning course. So moving ahead, you have 30 epochs, and the loss is shrunk down to 0.36, 0.0036, which is fantastic. Now let's see how well the model really is. So here the train loss, it has fallen from 0.3, which is pretty high, to 0.0036. Wonderful. And we'll see the predictions. So we are using the model that predict. In this case, we are naming a model as estimator, the predict of the training data, and identify the training error, the mean error, the minimum error, the maximum error, and the standard error. This and print all of them. This is the errors that we have got. So the least error is 0.02 in our prediction, and the maximum error is 0.24. Just see the actual versus predicted graph. So the green line is the actual, and the blue line is the values that are predicted using our deep learning models. So as you can see here, it has done a wonderful job in predicting whether a person can get admission into a university basis their GRE and TOEFL scores and their academic performances. So it's good to say that we have built a very powerful regressor using this deep learning framework. One add-on I would like to see is you building your own regression algorithm using scikit-learn to see if you can match up the numbers with this. So I'll be attaching a notebook in my GitHub for reference. So in addition, we will be using additional evaluation metrics. So these are the advanced metrics which are used in the industry, especially when you are put for a client-facing role as a data scientist. They would demand the R-squared score and the mean absolute percentage error. So let us see what these are now. So the R-squared score in statistics is the coefficient of determination, is the proportion of variance in the dependent variable that is predictable from the independent variable. In simple words, you can say that R-squared score is nothing but the amount of impact the independent variables have on the dependent variable. How well they can help predict the dependent variable. So we have the R-squared score of 0.26 here, and on the higher level, we have it at 0.81 for our estimator, for our deep learning model. So 0.81 is an impressive R-squared score. So R-squared score is a value between 0 and 1. Okay, so 1 means all the input variables excellently define the output variable, and 0 means they have absolutely no relationship. Moving ahead, we will use the mean absolute percentage error, my favorite regression metric, and a metric which I prefer as a data scientist in my industry. So the mean absolute percentage error, also known as mean absolute percentage deviation, is a measure of prediction of accuracy of a forecasting method in statistics. For example, in trend estimation, it is also used as a loss function for regression problems in machine learning. So that is the technical definition we have here. So as I said before, you can use the mean absolute percentage error. The function is provided here as a loss function in this algorithm when you're trying to build it on your own. So this is the formula. Nothing but the absolute difference between the actual and predicted value by the actual value, mean of it, into 100. So as the name says, mean absolute percentage error, we'll just do it. It's 9%. So 9% MAPE is pretty good, but I would like to see a better MAPE of around less than 5% for better usability of this model. So yes, that is it. We have successfully built a regression model using deep learning and have achieved a very good R-squared and a mean absolute percentage error and a wonderful graph for actual versus predicted values. So since you are done, we'll just go ahead and save the model as a JSON object. So this is for being used again and again in a more real world scenario. And yes, that's it. So that is the today's session. Just drop in the doubts if you have any. And with this, I'll be attaching the GitHub link for this notebook. So thank you.